Okay, get ready to do lesson 8.1, part 1 of classwork pre-calculus math today. And for today's lesson, you have 6 points that go into your notebook, students. 6 points here. And then 48 points will go into your classwork. 8.1, sequences in series, part 1. Students, put your name, date, period. If you're in my classroom, if you're homeschooling, put your due date here, okay? And then into our bell work for today, students, teachers, here's our bell work. Find, if possible, A, so you got A here, A minus B, and then B, be 2B minus 3A, here's your A and B. And then C would be AB, so AB. And then D down here will be B times A. So students, teachers, give your students about 5-6 minutes, and I'll see you in 6 minutes. Okay, welcome back for your solutions to today's bell work. Operations with matrices. So for A here, which is A minus B, A minus B should be 8, 1, and negative 3 and 7 here. 8, 1, so what do we have? 6 minus a negative 2, blah, blah, blah. You should have 8, 1 here, students, and negative 3 and 7. And then for over here, B, it'd be 2B minus 3A for B down here. So that comes out to negative 22, negative 7, 3, negative 18. Check your signs. If you're not coming up with this, then you need to go back to pre-algebra or something, because you should have your negatives together to get that one. And then for here for C, and oh, by the way, I do have pre-algebra. Go back into my YouTube site or into my PowerShow site, and you can find the pre-alg that will show using negatives. That's even 6th grade math, students, by the way. And then C over here would be A times B, A times B. You should come up with that, 18, 9. So 6 times C, was it AB here? Whoa. 6 times negative 2, and then blah, blah, blah. 6 times 3 would be 18, and 5 times C. 6 times 3, whoa. C, 6 times negative 2, and then 6 times 4. Why am I getting that? Oh, I know why. Row times column here. So 6 times negative 12 would be negative 12. And then 5 times 6 would be 30, so that's why you're getting your 18 here. So you have row times column, and then over here it'd be row, see, and then for that'd be your 18, and then for 9 here you'd have 6 times 4 is 24, and then 5 times 3 would be negative 15, that'd give you 9. And then for down here you go 3 times see, row times column, so 3 times negative 2 would be 6, and then 4 times 6 would be 24, so that'd be 18. And then for this spot here it'd be 3 times 4 to be 12, and 4 times negative 3 would be negative 12, so that'd be 0 there for C. And then for D, which is BA, B times A, so we flip it around, and again you go this times that, and you come up with negative 0, or rather you come up with 0, 6, 27, 18. It's like, you know, how do you get that? Well, B times A, so you have row times column here for 0. So row would be negative 2 times 6 would be negative 12, and then 4 times 3 would be positive 12. That's why you get your 0, etc. here. So you should come up with 0, 6 and 27, 18. This is going back a couple of sections, students. This should be a review for you. If you don't know this, then you need to go back to chapter 7, okay? We're in chapter 8, so let's go into our first slide here. In mathematics, the word sequence is used in much the same way as in ordinary English. Saying that a collection is listed in sequence means that it is ordered so that it has a first member, a second member, and a third member, and so on. Mathematically, you can think of a sequence as a function whose domain is a set of positive integers. Instead of using function notation, sequences are usually written using subscript notation. So there's your difference there, subscript notation versus function notation, as shown in the following definition. So this goes in your notebook, page 1, students. So, okay, so this goes in your notebook or your notebook guide. If you need notebook guides, email me at animatedpowerpointmathvideo@aol.com. Okay, so the definition of a sequence. An infinite sequence, say, is a function whose domain is a set of positive integers. The function values are a1, a2, a3, a4. These are subscripts here, and 8n here are the terms of the sequence. If the domain of a function consists of the first n positive integers only, then the sequence is a finite sequence. On occasion, it is convenient to begin subscripting a sequence with 0 instead of 1, so that the terms of the sequence become a0 or a0, a1, a2, and a3. So that sometimes you do begin with 0. The domain of the function is a set of non-negative integers. Let's start out with an example here. Example 1, writing the terms of a sequence. Write the first 4 terms of each sequence. So here's our sequence here. A to the n equals 3n minus 2. The first 4 terms of the sequence given by a to the n equals 3n minus 2 are, so here's our first 4 terms, 1, 2, 3, and 4. 3 times 1 minus 2 is 1, 3 times 2 minus 2 is 4, 3 times 3 minus 2 is 7, 3 times 4 minus 2 is 10. So that would be the first 4 terms of this sequence here. First term, second term, fourth term, for your information. That's what these are. Okay, so knowing that, the first 4 terms of the sequence given by, here's our next sequence here, 3n minus 2. So here they are, first, second, third, and well, our fourth here. So we have, again, we have 1, 4, 7, and 10 here for 3n minus 2. Okay, so 3 times 1, 3 times 2, 3 times 3, 3 times 4. Let's try one now. Write the first 5 terms of this sequence here. A to the n equals 2n plus 5. This is yours down here, students, 4n minus 7. So we'll concentrate on this up here. The first 5 terms, 2n plus 5. And for that, 2n plus 5, 2, 1, 2, 3, 4, and 5. And you get 7, 9, 11, 13, and 15. So 2... and then down here 2 times 5 plus 5 equals 15. So that's what you should have with the first 5 terms of this sequence. With positive signs here in the sequence is pretty easy. With a subtraction here, it's a little bit more involved, but you have to pay attention for that. And I'll let you do that, students, on your own. On to our next example here, writing the terms of a sequence. Example 2, write the first 5 terms of the sequence given by negative 1 to the nth over 2n minus 1. The first 5 terms of the sequence are as follows. So here's a1 here, and we plug in an a. Rather, we plug in a 1 here. We get negative 1. So negative 1 to the first power. 2 times 1 minus 1 will give us a positive 1. So negative 1 over 1 will be negative 1. And then for here, our 2 now would become a square. Negative 1 squared would be 1 over 4 minus 1 would be 3. So you get your 1 over 3 there. And then for our next one here, a to the third term here. So negative 1 cubed is negative 1. And then 2 times 3 minus 1 would be 6 minus 1 would be 5. So it would be a negative 1 over 5 for our third term. And then our fourth term here would be negative 1 to the fourth power would be 1. And then 2 times 4 minus 1 would be 1 over 7. And then we got our fifth term here. So negative 1 to the fifth power would be negative 1. 2 times 5 minus 1 would be negative 1 over 9. So that would be that C there. Set your graphing utility to sequence mode and enter the sequence. Use the table feature to create a table showing the terms of the sequence as shown. So this is our sequence here, 1, 2, 3, 4, 5. And then these are the solutions here in decimal form. So you can estimate the first 5 terms of the sequence as follows. So first term here is negative 1. Second term is 1/3. The third term is negative 0.02, which is negative 0.2. And then our fifth term here will be negative 1.5. That's not our fifth term, that's our third term. So our fourth term will be 1 over 7, which is the same thing as 0.14286. This is how it would look on your graphing calculator, students, when you enter that sequence into your calculator. And then our fifth term here would be the negative 0.11111, which is the same thing as negative 1 over 9. So that would be a screenshot on your calculator for that entry. Let's try one now. Write the first 5 terms of the sequence using A, the table feature of a graphing calculator, and B, here's A, here's B over here. So B is here and here. B algebraically, assuming n begins with 1. So for 17 here, we have a to the n equals 1 plus a negative 1 to the nth over n. So we need to write our first 5 terms there for that. And for the first term, we get 0, because, good gosh, that means that we would have 0 in the denominator here. So that would be, actually, that'd be undefined, but we just call it 0. And then 8/2, our second term, so it'll be 1 plus 1 over 1 here will be 1. So it'd be negative 1 squared here. That would give us a 1 here. And then a to the third would be a 1 plus a negative 1 cubed would be a negative 1. So that would be a 0 in our numerator. So that would be a 0. And then to the fourth power here, so that would make this positive. So that would be 2 over 4, which would be 0.5. And then our fifth term here to make this a negative again. So this would be a 0 up in your numerator, and then that would just make the whole thing a 0 then for that. So I think that's what they were doing here. Instead of making it, oh, we're going to call that undefined, it's actually 1 plus a negative 1, which will make it 0 right off the bat. Never mind the fact that, well, this would be 1 here. Our first term would be 1. I was mistaken. This would be a 1 down here for that. And then for B here, algebraically, so this is our original expression here, and then algebraically, this is how it works out here algebraically here. That this is your algebraic expressions of plugging in your values here into this sequence. This is a substantiation of what we did here. Okay, and then this one down here, you have a little difference here. You got a 2n down here, but it's basically kind of the same thing, students, so you should knock that out, no problem. Let's move on. simply listing the first few terms is not sufficient to define a unique sequence. The nth term must be given. To see this, consider the following sequences, both of which have the same first three terms. So we have this situation here where we go 1/2, 1/4, 1/8, 1/16. So you can say 1 over 2 to the nth power here. 1, 2, 3, 4. That would be what your n would equal to. And then down here, 1 over these numbers here would be n plus 1 multiplied by n squared minus n plus 6. So this is way more complicated than this up here. A little bit more difficult to see how you would arrive at these conclusions there from this expression. So they can get complicated. So example 3, finding the nth term of a sequence. Write an expression for the apparent nth term, a to the n of each sequence. So for 1, 3, 5, and 7, so write an expression for the apparent nth term. So we have n would be 1, 2, 3, 4, and then n. This would be our n, and then this is our output here. This would be our input, and then that would be our output there. So our terms will be 1, 3, 5, and 7. This is our output here. So this is our input, this is our output. So our output is a to the n. So apparent pattern, each term is 1 less than twice n. So each term is 1 less than twice n. So we have 1, 2, 3, and 4 will be our n. And then that is 1 less here than each one of these. So the apparent nth term is a to the n equals 2n minus 1. You know, arriving at this conclusion is 1 less than twice n here. So twice 4 would be 8, and that'd be 1 less that. Twice 6 would be minus 1 would be 5. Then twice 2 minus 1 would be 3, and then twice 1 minus 1 would be 1. So that would be one way that you can extrapolate or the expression that is suitable for that series. So 1, 2, 3, 4, and n. So terms would be 2, 5, 10, 17, and 8 to the n. So what's the relation between our input and our output here? Apparent pattern, each term is 1 more than the square of n. So 1 squared is 1 plus 1. Then 2 squared plus 1 would be 5. 3 squared plus 1 will be 10. Then 4 squared plus 1 will be 17. So that's how they're coming up with that. So we have n squared plus 1 will be our a to the n here. So you can just kind of like, you know, do it like that. So in these exercises, write an expression for the apparent nth term of the sequence. Assume n begins with 1. So write an expression with nth term. So here is our nth term of this here. So here are our terms 1, 4, 7, 10, and 13. So what would we do with that? 1, 4, 7, 10, and 13. So a to the nth would be 1 plus n minus 1 multiplied by 3. So when we multiply this through, we get 3 times n, and then 3 times the negative 1 would be negative 3. So it becomes 3n minus 2 by using this kind of like algorithm here for that. So 3n minus 2 would equal our term. So so if n equals 1, we have 3 times 0 will be 0 plus 1 will be 1. And then when n equals 2, this will be 3 times 1 plus 1 will be 4. And then when it's 3, it'll be 3 times 2 is 6 plus 7. And then when it's 4, it'll be 9 plus 1. And then 5 would be 12 plus 1. So that'd be the way that you would come up with these algorithms that fit that kind of output there. And that is our 8.1 Part 1 Pre-Calculus Math. If you need class worksheets, homework sheets, note-taking guides, email me at animatedpowerpointmathvideo@aol.com. Thank you very much.